All right. So we have just talked about the concept of interest and how it is evaluated. Now, theoretically, there are two types of interests, the simple interest and the compounding interest. Actually, in this course, throughout this course, we are not going to solve any further questions related to simple interest. Simple interest is very basic and helps us to understand the concept of interest. However, practically in real life, we use compounding interest. So let's start with this basic concept that is called the simple interest. And that simple interest is defined as a fixed percentage of the principal. All right, so how do we calculate the simple interest? It says when the total interest earned or charged is linearly proportional to the principal, the interest rate, and the number of periods for which the principal is committed. The interest and interest rate are said to be simple. So in this formulation, as you can see, we calculate the simple interest by multiplying the principal amount that is being borrowed with the interest rate per period and the number of periods that the principal amount is borrowed. Okay, so P is the principal amount that is being borrowed. I here is the periodic interest rate, which is expressed as decimal. Remember now, we are always using the decimal interest rates in our calculations, not the percentage rates. And the decimal interest rates are simply obtained by dividing the percentage interest rate to 100. And N here is the number of interest periods for which the principal is going to be kept by borrowed. And as you can see, by multiplying those, we get the interest amount as a linear function of these three components. Okay, so as you can see, the interest amount is linearly proportional to the principal amount or the interest rate or the number of interest periods. So let's use that formulation to calculate the future worth of an initial principal. Now, after a simple interest loan is made, in the end of the loan period, both the principal and the accumulated interest are repaid. So if you borrow the principal amount, in the end of the contract period, you are going to pay the principal amount plus the interest amount. So this total amount you are going to repay is called the future worth of the principal. Okay, so if you borrow $1,000 from me, and if you are going to pay me $100 of interest, this $1,000 and $100, their summation $1,100, which you are going to repay me in the end of the borrowing period, is going to be called the future worth of the principal. Future worth of the principal. Now, in the simple interest calculation, the interest amount I here is calculated as the number of interest periods times the periodic interest rate times the principal amount. Therefore, the principal amount plus NIP gives you the future worth of the borrowed principal. And if we take the principal amount as a common multiplier here, the formulation is going to be simplified as P times 1 plus NI. So the future worth, when you are subject to simple interest, the future worth of the principal that you have borrowed is going to be calculated as P times 1 plus the number of interest periods and the interest rate as decimal. Now let's use that formulation in a practical example. A student borrows $3,000 from his uncle in order to finish school. His uncle agrees to charge him simple interest at the rate of 5.5% per year. Suppose the student waits 2 years and then repays the entire loan. How much money will he have to repay? Now, in this question, let us understand everything from scratch. So the student right now. So this is the principal amount that is being borrowed. In this question, the keyword is the simple interest. So the student is going to be subject to simple interest. So if we are going to make an interest calculation, you need to use the simple interest formulation. Now, the interest rate here is 5.5%. Remember, when you are writing an interest rate, you need to write the period where the interest is applying. So this is a 5.5% per interest. This is the annual interest rate, yearly interest rate, 5.5%. Now, remember, in the following 4 weeks, we are always going to solve questions where the interest period is always yearly. However, in real life examples, the can be applied on monthly basis or quarterly basis or weekly basis or daily basis. However, here we are just going to focus on yearly interest applications in the following 4 weeks. So here we have a 5.5% per year interest rate that the student is being subject to, and this is a simple interest because the uncle is applying that interest. Suppose the student waits 2 years, it says, so the total borrowing time, the borrowing period of this loan is 2 years, and then the entire loan is going to be repaid. How much will he have to repay? Now, according to this question, the principal amount is 3,000. The interest rate as decimal per year is 0.055. Remember now, we do not use the percentage interest rates in formula. We always convert it to decimal, and the decimal representation of this interest rate is obtained by dividing 5.5 to 100, which is 0.055. And the number of interest periods that the student is being subject to is 2 periods. So 2 years from 0.055 simple interest. Now, the future worth, the total amount of money that the student needs to repay to his uncle is 3,330. Now, this 330 is the interest amount, and because initial principal is 3,000, a total amount of money, which is $3,330, is going to be repaid in the end of the 2 years under simple interest. Now, in real life, actually, in practice, nobody use simple interest. Okay, if you borrow money from bank or a credit company, you are always going to be subject to compound interest. So what is compound interest? Let me explain this through an example. So whenever the interest charge for any interest period is based on the remaining principal amount plus any accumulated interest charges up to the beginning of that period, then the interest is said to be compound, it says. Now, imagine the previous example. We have borrowed $3,000 from our uncle, and we are going to be subject to, let's just focus on a simple interest rate in calculation, not the simple interest, but a much more easily a value which we can calculate much more easily. Let's just say the interest that we are subject to 10%. Okay, so borrow $3,000 right now, and if you are subject to 10% interest rate per year, then in the end of the first year, the total amount that you are going to be in debt for your uncle is going to be $3,000 plus $300, right? So in the end of the first year, your total debt is going to increase to $3,300. Now, in the next year, if you want to keep that money for the next year without paying anything to your uncle, then your uncle is going to expose to you an interest over $3,300 right now, because your total debt increases to $3,300. This means you are basically borrowing $3,300 from now on. So in the next period, in the next interest period, in the next year, you are going to be exposed to an interest which is called as a percentage over the total debt. Okay, so as it is explained here, when you are going to calculate the interest charge for any interest period, any year, then your calculation will be made on the remaining principal amount plus the accumulated and not paid interest charges up to the beginning of that period. So this means what? If you are paying the interest of the interest as well, okay, not just the principal amount interest, you are also paying the total accumulated interest, then this interest is said to be compounding interest, okay, or we can say it's a compound interest. So let's see the calculations as formulations here. So for the first period, how do we calculate the interest? If we do a principal amount P, and if you multiply it with the periodic interest rate, yearly interest rate, so I1 is going to be the interest charge in the end of the first year. And the future worth in the end of the first year is going to be F1, which is the principal amount plus the first year's interest. That is going to be equal to P times 1 plus I, or P plus IP, which is P times 1 plus I. So this is the future worth of your principal in the end of the first year. And actually, this formulation is also consistent with the simple interest calculation, but only in the end of the first year. Now, for the second period, if you want to continue to keep this money, the second year's interest is going to be calculated over the future worth in the end of the first year. So in the end of the first year, this is the total debt that you are being subject to. And now the second year's interest is going to be calculated by multiplying the yearly interest rate with that future worth. And since this future worth, the total accumulated debt in the end of the first year is P times 1 plus I, this calculation here is going to be I times 1 plus I P. And in the end of the second year, your total debt is just going to be the principal amount plus the first year's interest plus the second year's interest. Now, this is the principal amount. The first year's interest was IP, and the second year's interest was calculated as I times 1 plus I times P. Now, after some simple algebra here, you can easily determine that this is going to be equal to P times 1 plus I to the power 2. So basically, if you want to calculate the future worth of your principal under interest rate I in the end of 2 years, then you need to multiply the principal with 1 plus I to the power 2, where this 2 stands for 2 years. And we can continue this operation. We can calculate the third period or third year's interest amount, which will be calculated over the future worth in the end of the second year, which is P times 1 plus I to the power 2. If you multiply the future worth in the end of the second year with the yearly interest rate, then that is going to be the interest that you are going to be subject or you are going to be charged for the third year. And the total future worth in the end of the third year of this principal will be P times 1 plus I to the power. And in general, if you continue like this for n interest periods, for interest period n, the interest amount that you are being charged is going to be calculated as previous year's future worth value times the interest rate, and the total debt or the total future worth of the principal in the end of the nth year is going to be P times 1 plus I to the power n. Now, unlikely to the simple interest calculation. Remember now, in simple interest calculation, if we go back to previous slides, in the simple interest calculation, the future worth was a linear function of the number of interest periods. However, here you can see that the future worth under compounding interest is a function of the number of interest periods as an exponential function. Okay, it's an exponential function of the number of interest periods. The future word is calculated as p times 1 plus I to the power n. N here is in the power. Now, let's solve the previous question where the student borrows $3,000 from his uncle under the assumption that the uncle is exposing the student to a compound interest at the same percentage of interest rate. So again, the student is going to be subject to 0.5% per year, and borrowed money is $3,000, and the student is just going to wait for 2 years again and repay the entire loan in the end of the second year. How much will he have to repay? Now, this time, we are not going to use the simple interest. We are going to use the compound interest formulation, which is the principal amount multiplied with 1 plus I to the power n, where I is the yearly interest rate as decimal, and n is the number of interest periods. So 2 is the number of years that the student is keeping the money for, and 0.055 is the yearly interest rate as decimal. And as you can see, according to this formulation, the total amount that the student needs to repay is $3,339.08. Okay, now as you can easily see that this amount is $9.08 more than the debt that the student needs to pay under the simple interest rate. Okay, so compared to the previous question, the student pays $9.08. So where does this come from? Actually, this $9.08 is the interest of the interest that is accumulated in the end of the first year. So if you borrow $3,000 under 5.5% interest rate, now you need to have a $165 of interest in the end of the first year. Okay, so under this interest rate, your first year's interest is going to be $165. And because this is a compounding interest in this question, in the second year, you are not just paying the interest over the principal that you have borrowed, just in the simple interest example. This time, you are also need to pay the interest, which is calculated over the interest accumulated in the end of first year, which is $165. And over $165, if you intend to calculate a 5.5% interest, that is going to be $9.08. Okay, so basically in real world economics, the compounding interest apply. Okay, and under the compounding interest, we have a statement that is called equivalence. Okay, so how do we create an equivalence statement? Let's see. Let's just say we have a principal amount, which is $100, and it is invested in a compound interest account with 7% annual interest rate for 5 years. The future worth of the principal will be equal to F equal to P times 1 plus I to the power n. Okay, so if the same account is paying a compounding interest, then you need to use the compounding interest calculation to calculate the future worth, and that is going to be $100 principal times 1 plus 0.07, which is the annual compounding factor. Now, if you take this fifth power, if you take the fifth power of this compound factor, then you are going to calculate the compound factor for 5 years. Okay, so $100 times the compound factor for 5 years, which is 1 plus the decimal interest rate to the power 5. Remember now, 7% is the yearly interest rate, and 5 is the number of years. It is going to be approximately equal to 140.26. So you see, if you invest your $100 to a savings account which pays 7 annual interest rate under compounding principle, then after 5 years, your money is going to become $140.26. Okay. Now, in that statement, we can also say that $100 today is equivalent in value to $140.26 5 years from now under compound interest rate of 7%. So when you define an equivalence statement, you need to mention about two values and the timing of these two values and a certain interest rate, because an equivalence statement can only be defined under an interest rate. If there was no interest, if the interest rate was simply zero, then $100 today and $100 anytime would be equivalent. But under a positive interest rate, different amounts of money can be equivalent in value. So according to this statement, $100 today is equivalent in value to $140.26 5 years from now. But this is only equivalent under a compounding interest rate of 7%. Now, I am going to ask you this question. So you have a 7% compound interest rate savings account. Okay, if you have any money, you can invest that money into the savings account, and every year you can get a 7% interest over the money that is being kept in that account. Okay, so you have such an account, which is provided by the bank to you. Okay, now I am going to ask you the same that I have asked in the beginning of this week's class. Now, either I am going to pay you $100 today, or the second option, I am going to pay you $140.26 5 years from now. Which one would you choose? Now, your answer should be, it doesn't matter. Either one you can choose, because if you take $100 today, you can invest that money into your savings account, which pays you a 7% compounding interest per year. Then your money is automatically going to become $140.26 in the end of the 5th year. Or you can simply take the same amount of money from me 5 years from now. So both options are equivalent. Okay, so this is how we create an equivalence statement. In order to an equivalence statement, we need to assume an interest rate that was 7% in this example. And equivalence is a symmetric relationship. Now, you can also say that $140.26 5 years from now under compounding interest rate of 7% is equivalent in value to $100 today. Okay. Now, you can say that the future worth of $100 principal 5 years from now under 7% compounding interest rate per year is $140.26, or you can say the vice versa, the opposite. The present worth of $140.26 5 years from now is $100 under compound interest rate of 7%. So the present worth of 140.26 years in the end of the 5th year is $100 today. Okay, so future worth is the future value, present worth value. But if you want to define such a present worth or future worth statement or equivalence statement, you always need to assume a interest rate. You need to mention about an interest rate and the number of interest periods. Okay, so how do we calculate the present worth then? Actually, it is very easy, because you already know how to calculate the future worth from the principal amount. Now, the principal and the present worth, they represent the same thing. Because of that reason, they are both represented by P. Their initial letters are the same. So if you calculate the future worth of a money under compounding interest rate as P times 1 plus I to the power N, then you can simply take everything on the left-hand side except P, and you can basically do that by taking this compounding factor 1 plus I to the power n to the denominator of the future word, or you can simply write f times 1 plus I to the power minus n. That is going to help you to calculate the present word from a future value. Now let's practice this in this simple question. A student who will inherit $5,000 in 3 years has a savings account that pays 5.5% per year compounded annually. What is the present worth of the student's inheritance? Now here in this question, please be careful. The student is going to get that money in 3 years, not now. He or she is going to take that money in 3 years, in the end of the 3rd year. Now, the student has a savings account right now. If money was given right now, the student can invest that money into the savings account, and he or she could have got 5.5% interest rate compounding per year in every. Now, in this question also, it mentions about a term, compounded annually. Annual means yearly. So annually or yearly, so the interest is being compounded annually, which means this 5.5% interest rate is compounding in every year, okay? So what is the present worth of students' inheritance, it says? So right now, the student, if the student has some money, he could have invested, or she could have invested that money into the savings account. Now, how much money should he or she invest right now so that money becomes $5,000 in 3 years? So the question is basically asking this: what is the present worth of this $5,000? So if you want to get a total of $5,000 in the end of the 3rd year from the savings account, much money should you invest right now in that savings account? Okay, so this question is asking that in a different perspective. It asks it as the amount 5,000 that the student is going to get in 3 years from now. What is the present worth of it? So what is the present worth of this $5,000, which is going to be paid to the student in the end of 3rd year if the student has a savings account that pays 5.5% yearly compounding interest? Now, how do we calculate the present worth? Again, by using the above formulation. So either we divide the future word to 1 plus I to the power n, or you can simply apply this formulation by taking this 1 plus I to the power n to the numerator by changing the power sign. Now, if you divide the future word to 1 plus the yearly interest rate, which is 0.055 as a decimal interest rate, to the power 3, where 3 is the number of interest periods, this is going to be the present worth of $5,000 3 years from now, which is $4,258.07. Now, if the student has $4,258.07 right now, this student can invest that money into the savings account, which compounds at a yearly interest rate of 5.5%. And in the end of 3rd year, student would already have $5,000 in that account. Okay, therefore, the $5,000 that the student is going to inherit 3 years from now has a present worth which is equal to $4,258.07. Or in other words, $4,258.07 today is equivalent in value to $5,000 3 years from now under a 5.5% yearly interest rate that compounds annually. So we have also written an equivalence statement here. All right. So we are going to complete this presentation in the next video.